Welcome to our series for non-parametric statistics. In this video, we will learn Spearman Rank Correlation, one of the most widely used non-parametric techniques for measuring relationship between variables. Unlike Pearson's correlation, which works with actual values, Spearman correlation works with ranks. This makes it particularly useful when data is ordinal, non-normal, or contains outliers. Correlation helps us to understand whether two variables move together. For example, as study hours increase, do marks increase? As customer satisfaction increases, does loyalty increase? Correlation does not prove causation. It simply measures the strength and direction of relationship. Pearson correlation is extremely useful, but it has assumptions. The variables should be measured on interval or ratio scales. The relationship should be linear and the data should be approximately normal. When these assumptions are violated, Spearman correlation becomes a useful alternative. Spearman correlation is ideal when data is naturally ranked. Examples include class rankings, customer satisfaction ratings ranking, preference rankings, Likert scale responses. Because it is ranked based, it is less sensitive to extreme observations. Let us work with a simple example. We want to know whether study hours and marks are related. At first glance, it appears that as study hours increase, marks also increase. But we need a statistical measure to confirm this relationship. The first step is ranking the values. The smallest value receives rank 1, the next value receives rank 2, and so on. We repeat the same process for marks. Now we rank the marks. Notice that both rankings follow the same order. This suggests a strong positive relationship. Now we calculate the differences between ranks. This difference is represented by D. Then we square each difference. Finally, we sum all D squared values. This is the Spearman rank correlation formula. Rs is equal to 1 minus C sigma D square upon N into N square minus 1. The coefficient ranges between minus 1 to plus 1. A value close to plus 1 indicates a strong positive relationship. A value close to minus 1 indicates a strong negative relationship. A value near 0 indicates little or no relationship. Substituting the values into the formula for the given example gives a coefficient of 1. This indicates a strong positive relationship between study hours and marks. The interpretation is straightforward. Students who study more tend to obtain higher marks. As one variable increases, the other also increases. Now let us implement the Spearman correlation in SPSS. We choose analyze, then correlate, then bivariate, then select Spearman and run the analysis. Let us work on SPSS. So we have got students A, B, C, D, E. They work daily for 2 hours, 4 hours, 5 hours, 7 hours, 8 hours. And they get the mark 45, 42, 58, 72, 80. Now we want to find out the Spearman's correlation. What do you have to do? Analyze, correlate, bivariate, and put both this thing hours and marks as variables. You have to select Spearman. Don't select Pearson. See, we have already told you the Pearson takes the actual values, but Spearman takes the ranks. So flag significant correlates. So there is no need for options and bootstraps, etc. So say OK, and you will get this thing that the correlation is 0.90 between the two, 0.90, and the significance level is 0.037, and it says correlation is significant at 0.05 level, 210. So the hours and marks are highly correlated because it is significant less than 0.05. After working on SPSS, SPSS reports two important values. The correlation coefficient tells us the strength and direction of a relationship. The significance value tells whether the relationship is statistically significant. Python makes Spearman correlation extremely simple. The Spearman R function directly provides the correlation coefficient and p-value. Let us work on Python. Let us start this Spearman's correlation with Python. I have already started Jupyter, and the simple commands are from SciPy stats import Spearman R. Hours 2, 4, 5, 7, 8. Marks 45, 42, 58, 72, 80. Correlation comma P is equal to Spearman R hours comma marks. Print correlation, that will be printed within commas. Correlation CORR dot round 3. It will round up to 3 decimals. Print p value p dash round 3. If you don't want rounding up to 3, don't write this round. You can directly start. Let us now run this cell. When you run this cell, it simply says correlation is 0.9, p-value is 0.037. It means it is less than 0.05, which means there is a strong correlation between the ranks, not the actual values. Spearman calculates correlation on ranks. So this one is correlation 0.9, p-value 0.037. After seeing both SPSS and Python, now we have to compare the Pearson's and Spearman. This comparison is extremely important. Spearman works with actual values. Spearman works with ranks. Pearson measures linear relationship. Spearman measures monotonic relationship. This is how you should report the results in a thesis, dissertation or research paper. Always report both the coefficients and the p-value. Thank you for watching. If you found this video useful, Please subscribe to the channel, share it with fellow students and researchers, and leave your questions in comments. In the next video, we will study Kendall's-Tau correlation, another important non-parametric measure of association. Thank you.
Always share the videos of Dr. Sachdeva to your friends who are interested in data analysis.